Meet LHS 1140b, a super-Earth located in the Cetus constellation, which might be one of our best chances to find life beyond Earth. Astronomers at the University of Montreal have been studying this planet for a while. Initially, it appeared to be just another barren exoplanet, nothing too special. However, new data from the James Webb Space Telescope reveals that LHS 1140b is far more intriguing than previously thought. It is classified as a super-Earth because it is nearly 6 times more massive than our planet. With its larger radius, the gravity there would be much stronger, and any life that exists would likely be very different from what we know. When LHS 1140b was first discovered in 2017, astronomers believed it was a mini-Neptune with a thick atmosphere made of hydrogen and helium. But here's the exciting part: recent observations using the powerful instruments of the James Webb Space Telescope show that this hydrogen-helium atmosphere is actually not there. Instead, scientists found evidence suggesting that LHS 1140b might have a nitrogen-rich atmosphere, similar to Earth's. If LHS 1140b truly has an atmosphere like ours, it could also have massive oceans of liquid water, possibly even larger than those on Earth. Since liquid water and nitrogen are key ingredients for life, this discovery makes LHS 1140b a prime candidate in the search for alien life. Unlike Earth, however, this planet is tidally locked to its red dwarf star. This means that one side of the planet is always facing the star, while the other remains in permanent darkness. The side facing the star would have melted ice, creating vast oceans, while the far side would remain frozen, making the planet resemble a giant, icy eyeball in space. In the temperate zone between these extremes, where ice meets liquid water, there's a chance that some form of life might exist. Despite the excitement, confirming the presence of water and other conditions necessary for life won't be easy. The James Webb Space Telescope has a limited viewing window for LHS 1140b, only about 8 times a year. On top of that, competition for telescope time is fierce, so it may take years before scientists can gather enough data to confirm their theories. If future observations confirm that LHS 1140b is covered in water, it could be an enormous ocean world, possibly teeming with unknown alien life. But this is just one of many exciting discoveries made by the James Webb Space Telescope. In June 2024, astronomers from the University of St. Andrews identified not 1 but 3 potential super-Earths orbiting an orange dwarf star about 55 light-years away. Only the third and farthest planet from the star is located in the habitable zone, making it the most promising candidate for life. What makes this discovery even more exciting is that the orange dwarf star is more stable than other types of stars, meaning it doesn't bombard its planets with harmful radiation. The 3 super-Earths found around this star have masses ranging from 5 to 11 times that of Earth. Scientists are particularly focused on the third planet, which orbits the star every 151 Earth days. If conditions are right, life could very well exist there. Using high-resolution imaging techniques, astronomers hope to study this planet in more detail. Only time will tell if we'll find life there, but every new discovery brings us closer to answering the age-old question: are we alone in the universe? The James Webb Space Telescope has not only found potentially habitable exoplanets but has also made other groundbreaking discoveries. One of its most astonishing finds is a direct image of the gas giant Epsilon Indi b, located 12 light-years away. Seeing a planet at this distance is an incredible achievement. Even more surprising, this exoplanet, the coldest one ever found, is not as freezing as expected. Instead of being an icy wasteland, it has a temperature of around 35 degrees Fahrenheit 1.6 degrees Celsius, making it much warmer than expected. This moderate temperature suggests that gases like carbon dioxide, methane, and carbon monoxide might be present, compounds that could indicate the possibility of life. Epsilon Indi has been a popular setting in science fiction, appearing in Star Trek and the Halo video game series. The fact that we now have real images of planets in this system is thrilling for both scientists and space enthusiasts. But what about planets that don't orbit a star at all? The James Webb Space Telescope has also found 6 bizarre planetary objects in the NGC 1333 star cluster, about 960 light-years away. These so-called zombie planets are massive, about 5 to 10 times the size of Jupiter, yet they don't orbit any star. Instead, They formed in a way similar to stars but never gained enough mass to start nuclear fusion. While the chances of life on these planets are extremely low, their existence challenges our understanding of how planets and stars form. The telescope has also discovered a zombie galaxy, a galaxy that stopped forming stars for about 20 million years and then suddenly came back to life. This discovery provided an important clue about our own Milky Way, revealing that it, too, went through a dormant period billions of years ago before restarting star formation. Astronomers have also been studying Gliese 667, a triple star system about 23 light-years away in the constellation Scorpius. The smallest star in this system, Gliese 667c, has at least 6 planets, and 3 or even 4 of them could be habitable super-Earths. These planets have masses between 1 and 5 times that of Earth and orbit within the star's habitable zone. One of the most intriguing planets, Gliese 667cc, is nearly 4 times Earth's mass and orbits its star every 28 days. Because its star is a faint red dwarf, the planet receives mostly infrared light, yet it gets roughly the same energy that Earth gets from the Sun. If it has an atmosphere, it could support liquid water and even life. However, since red dwarfs often produce powerful solar flares, this could make life on the surface challenging. Additionally, since Gliese 667cc is likely tidally locked, one side of the planet may be permanently scorched while the other remains frozen. Despite these challenges, the possibility of multiple habitable planets within one system is exciting. Scientists continue to study these worlds in hopes of learning more about their atmospheres and potential for life. The discoveries made by the James Webb Space Telescope have been nothing short of revolutionary. From potential ocean worlds to rogue planets and zombie galaxies, the universe continues to surprise us. As technology advances and telescopes improve, we may one day find definitive proof of life beyond Earth. Until then, the search continues, and each new discovery brings us closer to answering one of humanity's biggest questions. Are we alone? The James Webb Space Telescope has revealed surprising findings about a distant planet. Scientists initially thought it had a thick atmosphere similar to Venus, but they were wrong. While the planet's day side remains extremely hot at about 225 degrees Fahrenheit, it is now considered the coldest rocky planet ever studied using this method. In such extreme conditions, any water that may have existed would have evaporated long ago. However, a new study suggests that other parts of the planetary system could still be cold enough for water to exist in liquid or frozen form. The lightest planet in this system, TRAPPIST-1d, has only about 30% of Earth's mass and is approximately 80% of Earth's size. Because of its small mass, it likely lacks a thick atmosphere or heavy elements, but it still shares some similarities with Earth. It receives a similar amount of solar radiation from its star and is located near the inner edge of the habitable zone. If it had no atmosphere, its temperature would be around 48 degrees Fahrenheit. To compare, if Earth had no greenhouse effect, its surface temperature would drop to about 0 degrees Fahrenheit. One of the most exciting aspects of TRAPPIST-1d is its potential water content. It could hold up to 250 times more water than Earth. While its habitability is still uncertain, one important factor could influence this: albedo, which measures how much sunlight a surface reflects. Albedo values range from 0, a perfectly black surface that absorbs all light, to 1, a perfectly white surface that reflects all light. Earth's average albedo is 0.3. If TRAPPIST-1d has a similar value, it might create conditions that prevent a runaway greenhouse effect, making it more suitable for life. Scientists believe TRAPPIST-1d is covered by a massive global ocean. However, for life to exist, the planet would need a tidal heat flux 20 times stronger than Earth's. Tidal heat flux is energy generated by the gravitational pull of nearby celestial objects. On TRAPPIST-1d, this energy could act like geothermal heat, fueling chemical reactions in its deep ocean. Some life forms on Earth survive using chemosynthesis instead of sunlight, so it's possible TRAPPIST-1d could support unique life forms that don't rely on photosynthesis. If it has a thin atmosphere, its twilight zone, the region between its day and night sides, could also be a habitable area. Among the planets in the TRAPPIST-1 system, TRAPPIST-1e is the most promising for life. It is dense, likely rocky, and similar to Earth in composition. Positioned in the habitable zone, It may have a thick oxygen-rich atmosphere. The lightest gas, hydrogen, would have escaped over time, which is beneficial since hydrogen is a greenhouse gas. If TRAPPIST-1e originally had more water than Earth and Mars and managed to retain it, its climate might be similar to our own. This makes it one of the most Earth-like planets ever discovered. Life on TRAPPIST-1e would be very different from Earth. A year there lasts only about 7 Earth days. Because of its close orbit, the planet is tidally locked, meaning one side always faces its star. This would create a world of eternal sunrise or sunset, where the sky appears reddish. Other planets in the system would be visible in the sky, some appearing larger than the Moon. The day side might have land where humans could live, though the weather would be extreme, with thick storm clouds, massive dust storms, and strong winds. The night side, however, would be icy and covered in towering glacier, making it a hostile environment. Despite the endless twilight, this fixed sky could be useful for early settlers. Unlike Earth, where constellations shift, TRAPPIST-1e's sun would always stay in the same place, acting like a permanent North Star. This could help navigation across the alien landscape. Its host star, a red dwarf, is much smaller and dimmer than our Sun, but there are 10 times more of these stars in the galaxy, making them potential cradles for life. One challenge, however, is that red dwarfs often release powerful solar flares. These flares can be harmful, stripping away atmospheres and exposing planets to intense radiation. However, some scientists believe these flares could also provide the energy needed to form essential molecules for life, such as amino acids. TRAPPIST-1's flares are milder than those of other red dwarfs, but since its planets are closely packed, their effects would still be noticeable. This means that TRAPPIST-1e would likely experience dazzling auroras, far more intense than those on Earth. Since human bodies are sensitive to radiation, these solar flares would pose a significant risk. Long-term exposure could damage DNA, cause mutations, and lead to serious health problems. To survive, future colonists would need strong protection, including a thick ozone layer, a powerful magnetic field, and advanced technology to track and respond to flare activity. They might live in heavily shielded underground bunkers or specially designed habitats to stay safe from radiation bursts. Gravity on TRAPPIST-1e is about 93% of Earth's, so movement wouldn't feel very different. However, farming would be a challenge due to the planet's dim lighting. Since sunlight reaches the surface at a low angle, shadows would limit plant growth. To solve this, humans could create tiered gardens similar to the Hanging Gardens of Babylon, allowing plants to catch sunlight from multiple angles. These structures would resemble vertical farms, making the most of the available light. If native plant life exists on TRAPPIST-1e, it may have evolved to be completely black, maximizing sunlight absorption. Some plants might even produce their own light through bioluminescence, glowing softly in the dim environment. This could create an otherworldly landscape where glowing vegetation illuminates the planet's surface, offering a fascinating glimpse into a world that operates very differently from our own. This adaptation would allow plants to grow for longer periods and increase their chances of survival in the planet's constant twilight. TRAPPIST-1f, which is farther from its star, gets only about 1/3 of the sunlight Earth receives. Because of this, the planet is much colder. Without an atmosphere, its surface temperature would be around -74 degrees Fahrenheit, which would freeze any water into ice. The same applies to the two outermost planets, TRAPPIST-1g and TRAPPIST-1h. Although they appear to contain a lot of water, their surfaces would be covered in ice. However, TRAPPIST-1g is about 30% more massive than Earth, meaning it could retain an atmosphere. If this planet has kept a layer of heat-trapping gases and has active volcanoes that release greenhouse gases, it might still have liquid water. Scientists even speculate that it could have a deep underground ocean, possibly home to exotic life. The depth of this ocean could be around 4,155 meters, nearly twice as deep as Earth's average ocean depth. TRAPPIST-1h, the farthest planet in the system, gets very little heat from its star. If it were in our solar system, it would be located between Mars and Jupiter. Scientists estimate its surface temperature to be around -148 degrees Fahrenheit, making it an extremely cold and frozen world. TRAPPIST-1 is an old star, cooling for about 7.6 billion years since it first formed. In the past, the planets around it were exposed to intense heat. This should have caused any water on their surfaces to evaporate into the atmosphere. Later, strong stellar winds would have likely pushed this water out into space. However, recent studies suggest that these planets might not have gotten hot enough for their crusts and mantles to melt completely. This means that a significant amount of water could still be trapped inside their rocky interiors, even after the star cooled down. Right now, conditions on these planets are extreme. But because red dwarfs like TRAPPIST-1 have very long lifespans, these planets will continue evolving for billions or even trillions of years. Over time, what is now a harsh environment could transform into a place where life can exist. Many studies suggest that life is more likely to emerge around red dwarfs than stars like our Sun. And since red dwarfs are the most common type of star in the universe, the chances of finding habitable planets around them are much higher. In 2023, astronomers discovered an interesting exoplanet orbiting a red dwarf star called TOI 715, located 136 light-years away in the constellation of Volans. In cosmic terms, this is relatively close to us, like a neighboring house down the street. This red dwarf has a planet called TOI 715b, classified as a super-Earth because it is 3 times more massive than Earth and has a radius about 1.5 times larger. For an exoplanet to be considered habitable, it must be rocky or a water world. Scientists analyze a planet's size and mass to predict its composition and determine whether it has a solid surface or is mostly gas. Planets between 2 and 10 times the mass of Earth, with a size between Earth and Neptune, are usually rocky. What makes TOI 715b particularly exciting is its location. It orbits at the right distance from its star to potentially have liquid water on its surface. And where there is water, there could be life. Many red dwarf stars have multiple planets packed tightly within their habitable zones, and astronomers suspect that TOI 715b might not be alone. They believe there could be another planet in the system, about 7% larger than Earth. If confirmed, it would be the smallest exoplanet ever found in the habitable zone using NASA's Transiting Exoplanet Survey satellite, TESS. Finding planets like TOI 715b is an important step in our search for habitable worlds. Even though we still know very little about this exoplanet, its discovery raises exciting possibilities. Future observations might reveal whether it has an atmosphere or even bodies of liquid on its surface, similar to the lakes and seas found on Saturn's largest moon, Titan. If that happens, it would be a major breakthrough in our search for alien life. Unfortunately, not many exoplanets we discover are habitable. In fact, most have extreme and hostile conditions. Some are so bizarre that they leave scientists wondering how they even exist. One such planet is located about 264 light-years from Earth and belongs to a rare category known as ultrahot Neptunes. LTT 9779b is one of the most unusual planets ever discovered. It is 5 times wider than Earth and reflects about 80% of the light from its star, making it the most reflective exoplanet known to us. In comparison, Earth only reflects about 30% of sunlight. This extreme reflectivity is due to its atmosphere, which contains thick clouds of metal vapor, including titanium. The planet experiences metal rain, with droplets of titanium falling from the sky. The problem is that, according to our current understanding, this planet shouldn't exist. Its dayside is so incredibly hot that water clouds, glass clouds, or even metal clouds should not be able to form. Yet, they do, challenging everything scientists thought they knew about planetary atmospheres. Astronomers have long believed that a star located extremely close to an exoplanet should strip away its atmosphere completely. However, the discovery of LTT 9779b challenges this assumption. Researchers compare its survival to condensation in a steamy bathroom. Just as cool air causes water vapor to condense, this planet's atmosphere, rich in silicate and metal vapors due to its extreme heat, may have formed a dense reflective layer that prevented complete atmospheric loss. LTT 9779b is also significant because it falls within the Neptunian desert, a range of planet sizes previously missing from observations. Unlike other close-orbiting exoplanets, which are either hot Jupiters, much larger than Earth, or rocky planets, smaller than Earth, LTT 9779b fits in between. Its high reflectivity likely prevents it from absorbing excessive heat, enabling its continued existence. Future observations from the Hubble and James Webb Space Telescopes may reveal more about this enigmatic world. Another fascinating exoplanet, JWST-76b, is almost as hot as the Sun, twice as wide as Jupiter, and orbits its star at only 3% of Earth's sun distance. The extreme heat causes rock-forming elements like iron and magnesium to turn into gas in the atmosphere. As strong winds carry these vapors to the planet's cooler night side, they condense and fall as molten metal rain. Additionally, the planet's high nickel concentration suggests it may have absorbed a smaller rocky planet like Mercury in the past. Closer to home, astronomers have discovered a rare star system, HD 110067, just 100 light-years away. It hosts 6 sub-Neptunes in synchronized orbits, forming a mathematically precise resonance. Such planetary harmony is usually disrupted over time by gravitational influences, yet this system has remained stable for over 1 billion years. Beyond 1,000 light-years, the binary star system Bebop-1 has revealed a rare circumbinary exoplanet, Bebop-1c, which orbits 2 stars instead of 1. With only about 15 such known planets, this discovery adds to the growing evidence that many stars exist in multistar systems. Scientists estimate that only 15% of stars in the Milky Way are single like our Sun, while the rest have one or more stellar companions. A breakthrough discovery has also emerged from GJ9827d, an exoplanet twice the size of Earth with surface temperatures similar to Venus. The Hubble Space Telescope has detected water vapor in its atmosphere, the first direct proof of a watery atmosphere around an exoplanet orbiting a star unlike the Sun. This suggests that some planets may form farther from their stars in icy regions before migrating inward, retaining traces of water. Scientists are also refining their search for habitable worlds using atmospheric carbon monoxide levels. If CO production outpaces removal, it may indicate a planet's potential for life. This method helps astronomers pinpoint Earth-like exoplanets in the vast Milky Way, where an estimated 40 billion such planets could exist. One promising candidate is Kepler 452b, the first Earth-like planet found in a Sun-like star's habitable zone. It is 1.6 times Earth's size and receives 10% more solar energy than Earth. With 6 billion years in the habitable zone, it may have had a head start in developing life. However, its stronger gravity would make movement challenging for humans, though over generations, evolution could favor stronger physiques adapted to the environment. Kepler 452b's conditions may not last forever, as it could experience a runaway greenhouse effect in 500 million years, similar to Venus. Another exciting discovery is Kepler 186f, the first Earth-sized planet found in a habitable zone. Located around a red dwarf, it receives only a third of the heat Earth gets from the Sun. However, its stable axial tilt suggests a consistent climate, making it more favorable for potential life. The planet is 500 light-years away, but a spacecraft traveling at 90% of light speed could reach it in about 550 years. Kepler 1649c, initially overlooked in past observations, was later identified as another promising Earth-like exoplanet. Though little is known about its atmosphere, it receives 75% of the light Earth gets and has a short 19.5-day orbit, suggesting similar temperatures to our planet. A second planet, Kepler 1649b, also exists in the system, with an unusual orbital ratio hinting at a possible third, hidden world. Further away, Kepler 442b is another notable exoplanet orbiting a stable K-type star, which is cooler and longer-lived than our Sun. The planet's distance from its star prevents tidal locking, allowing for more stable conditions. It has been ranked high on the Comparative Habitability Index, scoring 0.84 on a scale where 1 represents perfect Earth-like conditions. However, direct imaging is currently impossible, and traveling to this distant world would take 1.7 million years with current technology. Despite the challenges of space travel, these discoveries fuel the search for Earth 2.0.